to hold the mic? Okay, good, I'm gonna feel silly. Okay, so I'm going to talk about how to work with Kafka and Hadoop together. For those of you who don't know me, I'm Gwen Shapira. I work as a software engineer in Cloudera. Cloudera is a small company with a nice Hadoop distribution. If you're not using Hadoop, I'm guessing this presentation is not going to be all that useful for you, but let's assume that everyone uses Hadoop. I like making this assumption. Before working for Cloudera, I have a long history working with relational databases. I worked as a consultant, trying to get people to make their Oracle database faster, and then trying to get people to make their Hadoops faster, and then trying to get people to use Hadoop at all because they weren't even good at that, and then figuring out that, hey, working with Hadoop is fine once you actually manage to get data on Hadoop. So now I'm on the team that works on problems of getting data onto Hadoop. And I'm working on Flume, Scoop, and Kafka as the tools that help people get data onto Hadoop. I've even written a book with some of my colleagues on how to build architectures and systems on top of Hadoop. If you have Hadoop, we hope it will be useful. And we started a new blog. It's called Ingest Tips, and you go to ingest.tips, and we have blogs on how to get data to Hadoop. So the tips include tips on how to use Kafka, tips on how to safely use the high-level consumer, a bunch of nice stuff that you may or may not find useful. So, getting to business, how do we get data from Kafka to Hadoop? It should have been so simple. I mean, you read data from one system, write it to another. How difficult can it be? I'm not saying that there is not a lot of ways to do it, which there are. It's just that every single way has a bunch of limitations and a very specific fit for purpose. So you have to not just find the best one in general, find the best one for you. So I'm basically going to review pretty much everything that exists today and let you figure out which one will actually work for you. And I also talk a bit about how we're planning to improve at least some of them. So Camus is probably one of the most well-known ones. It was written by LinkedIn, and it's a batch tool. And it starts a MapReduce job, and the MapReduce jobs reads data from Kafka and writes it to HDFS. And the nice thing is that they implemented exactly one semantics, which, as was already mentioned, you have to do some stuff about it. So it's exactly once from Kafka to Hadoop. If the data was written to Kafka multiple times, we can't help you with that. But at least the Hadoop part will be exactly once. It's not exactly trivial to do exactly once to Hadoop because Hadoop has a preemptive job processing. If a job is too slow, it will start another one. Jobs can get killed, jobs can get restarted. So it's not exactly trivial. So they actually had to come up with what is a remarkably complex architecture to do it. So they start by going to Zookeeper and picking up the offsets from all the partitions. And they're persisting the offsets to HDFS. And they're grabbing both the early and the late offsets. So they kind of have to figure out the entire range that they're going to get data from in the beginning. So data that arrives after the job already started will be ignored. That's part of the ways they can do exactly one semantics. After everything is persisted on HDFS, they split the job because MapReduce jobs have splits. And they start getting the data, and they write it to a temporary location. If a job gets killed, the file will not get moved to the permanent location and can just be ignored. It will get deleted eventually. So that's where we get exactly once semantics. We basically get data from Kafka, write it to HDFS. When the job finishes, the data becomes permanent. And we also get audit counts. So one of the nice things about Camus is that it can count how many rows were processed and in how much time, etc., from each partition, and it writes it back to Kafka. So if someone is very interested in that information, he can go back to Kafka and say, so that's the rate in which you are getting data, that's when the jobs run, etc. Really, really cool stuff. It has some stuff that we don't like, so some things that we feel that are missing. So one thing is that Camus is fantastic, but it's an entire job. If what you actually want to do is create your own MapReduce jobs that will do some processing in the middle, that will maybe write the data to HBase and not to HDFS, all kinds of stuff, you have to rewrite Camus, basically. Pick it up, change some stuff, And tons of people did that. Or write your own MapReduce job, which will probably end up being not quite as good as Camus. So we really think that almost every project in the world has MapReduce layers that gives you an input format, an output format, and a bunch of utilities, maybe a job you can inherit from, maybe a mapper you can inherit from, things that make your life easier. So HBase have it, MongoDB has it, Avro has it, so many stuff has it. Why doesn't Kafka has it? Good question. So I think this should go. The other sort of thing we think is missing is that we have a scoop. And scoop is a fantastic way to get data in batches. Currently, it works mostly on relational databases, but we can't figure out a single reason why not to have it work on Kafka as well. Why does Kafka need its own tool when relational databases kind of have this generic tool that's already working? And there's so many features that exist in scoop that will be nice to have applied to Kafka. So you can write data to Parquet files or to Avro files, or you can transfer data to a relational database from Kafka, for example. You can do cool stuff with that. So why not? That's pretty much it for batch processing. But I have to tell the truth, the reason we're not working very hard on that is that we haven't seen that many people who are actually interested in batch processing with Hadoop. I mean, Hadoop and Kafka with the batch use case. I mean, I'm sure they exist. Obviously, LinkedIn is one, but I didn't run into that many of them. So let's look at what we have for streaming. And the first one is, yes, we took the well-known Flume, which was actually, it's funny how Kafka got started as a replacement for Flume, but it ended up not really replacing a lot of what Flume is doing. So we figured out that Flume and Kafka actually make a pretty good system. So how does it work? Well, the way Flume works is that it has sources, and then it has a bunch of stuff the data goes between. It has interceptors that can modify the data, selectors that can kind of split the data multiple ways, channels that are supposed to persist the data or not, but basically turn the data into small batches, and then the sinks where the data goes. So, for example, the source can be Twitter or a bunch of logs, which is the original use case, or maybe a web server, or it can be Kafka. You can get data from Kafka to HDFS or HBase using Flume and the Kafka source. And then you have interceptors where you can put your own logic. It can do data masking, it can do reformatting of the data. You have JSONs, you want XMLs, or more likely you have XMLs and you want to die. And thank you. You want to do some data validation or a bunch of other stuff. Selectors allow you to split the data. So if you have, for example, a stream of logs, but you want errors to go to HBase and be handled immediately, while everything has to go to HDFS, that's where you do it. We have the channel. As I said, the data can be persisted to a file, so if something crashes, we can get the data back. And then over there at the end, the data can get sent to HDFS, HBase Solr, or Kafka. So if you, for example, did not use the Kafka source, you actually got data from Twitter, but you want the data to end up on Kafka, we have a Kafka sync for you to get data the other way. It's a horribly long way to get data all the way to Kafka, but if you want logs and you don't want to write your own something that reads the files from directory and tracks the location of the file and all that, you can do it. But as I mentioned, it's a horribly long way to get data from one place to another. There's tons of logic in between, there's batches. We cannot figure out why would you necessarily want to do that. You just want data from Kafka to HBase or HDFS. So the next thing we came up with, and it's not released yet at all, it's not even, we don't even have a patch upstream, is having a Kafka channel. So you use whatever you want to write to Kafka, and then you just apply the HDFS sync. So the channel is Kafka, and this gives us awesome stuff, because if you do use it with the full pipeline, which we had like a page or two ago, if you plug Kafka in the channel, and you use Flume you currently use Flume for anything else in the world, you suddenly have a highly reliable channel in there. So if a machine crashes, you don't lose your data. It's pretty awesome. But if you don't use Flume and you just have data in Kafka and you want to land it on HDFS or HBase, which is a very common use case, just create a Kafka channel, get a sync, HDFS sync, HBase sync, connect them to each other, and you're good to go. This will come out soon and will be absolutely awesome. Okay, now to the more complicated. Those were the simple methods. It looked complicated. Those are the simple ways. Now to the complicated ways. So the previous methods were just, let's take event from, or message from Kafka and land it somewhere Hadoopy. In using Spark streaming, you actually declare that you want to do a lot in between, because this is a whole streaming solution. You have to install a bunch of stuff to do it. You have to do a bunch of programming. Camus doesn't require any programming or very little. Flume doesn't require any programming. Spark streaming means you have to write your own workflow, and usually you intend to do something in between. For those of you unfamiliar with Spark streaming, I hope you're at least familiar with Spark. If you're using Hadoop, you absolutely have to familiarize yourself with Spark, otherwise you will be obsolete in about a year or two. You don't want it to happen to you. Spark is absolutely taking over data processing in Hadoop, and you don't want to kind of miss that and find yourself in 5 years writing MapReduce in COBOL or something. So assuming you know Spark, you also know about RDDs, which is basically a collection that is partitioned and distributed and reliable that Spark gives you. Spark streaming basically creates one of those collections for every window of a second. So you say you want a new collection every second. It will take all the data that arrived from Kafka in the last second, will give you this collection, which is again partitioned, distributed, resilient, and so on. And then you can do whatever Spark processing you used to do just on this time frame. And you can also do a bunch of other stuff. You can do windowing processing. So if you want to keep aggregating on a bunch of partitions, you can do that. It gets a lot of fun. Storm is pretty much the same thing, except it's not. It's also stream processing. But with Storm, it doesn't have the idea that it creates those micro batches of events. So it doesn't wait for a second to collect all the events that arrive from Kafka. It will, generally speaking, if we don't include other projects like Trident, it will process one event at a time. Fantastic for low latency, because no matter how long it takes, you don't have to wait a second until you collected enough events. On the other hand, in terms of throughput, I am a very small believer in one event at a time. Like very small batches kind of lets you optimize the latency you want with the throughput you want. Because everything is more efficient when you can do it on a batch of data. Like if you want to go to a database and validate that what you're doing is the data you're looking at relates to something else, and you want to do it on a small batch because one database call versus gazillion database calls. On the other hand, you may not want to wait a long time. So say 50 millisecond batch is what you want, 20 millisecond batch, 3-second batch. I like micro batches. It lets you tune exactly what you need. Storm, while it does micro batches with Trident, it doesn't do them very well yet, unfortunately. What it does very well is single event processing. So if you don't care about throughput at all and all you want is the lowest latency possible, go with Storm. And it lets you create those topologies. So you have the spouts, and the spouts can read from, say, Kafka. And then you have those bolts. So one bolt can do a group by, and the other bolt can do a join, and another bolt can do filtering, and you kind of pack them on until you have the processing that you want. And it's more explicit than Spark. So in Spark streaming, you kind of program in Scala the way you normally would with a collection. And Spark streaming will figure out how to turn it into a graph of events, kind of like you write SQL and the database figures out how to turn it into a graph of actions. In Storm, you have to be pretty explicit about it. It's pretty good for some optimizations, pretty annoying for actually writing and reading the code. That's, again, personal opinion. Everyone loves Storm except me, basically. So I'm kind of taking the opportunity to rant about it. On the other hand, the integration between Storm and Kafka is fantastic. Like, bar none, it's absolutely amazing. And the one bug I found in their code when they're writing to HDFS, they're first sending the ACK to Kafka and then writing to disk, which is kind of horrible because it gives you a window when you can actually, the write to disk can fail. If someone here is contributing to Storm and wants to fix that, that will be I'm sure they will appreciate the fix. But other than that, it's very good integration. Again, the reason we see it as an ingest method is because you can have Kafka in one end and HDFS on the other hand. Now, I mentioned I've been doing databases for a long, long time, and I'm kind of an old school type of person. And I'm so old school that I don't really believe in unstructured data. I haven't seen one. All the data I've looked at had structure. It may take a while to find it, but eventually it had structure. And structured data has schema. So I'm a big believer that data has schema, whether you know it or not. If you don't explicitly have schema somewhere that everyone agrees on, it means that your schema is hard-coded in gazillion assumptions all over your code base. And you're in for a world of pain. Just as an example, I had a customer with geolocation data. They were absolutely sure that their geospatial shape files are schemaless, and they're very happy to just dump them into HBase until they find out that the date format changed. It used to be a long, and it turned into some kind of a formatted string. And oh my God, the amount of code they had to change, and they had to support the 2 versions for a while. Tons and tons of fun. So if you don't have schemas, you actually do have schemas and you don't know about it, which is horrible. Now, Kafka doesn't necessarily have to know about your schemas. But you write data with schema on one end of Kafka, and you read data with schema on the other end of Kafka, and you kind of want them to be able to communicate something about the schema somewhere in between. So we are sorely, sorely lacking some things that will let us actually do it. And there's a lot of homegrown projects in many different places that kind of let you do it. And obviously, one method can be have an Avros file event, and then you have the actual schema in every event. That's horrible. That's really, really horrible, because Avros schemas can get pretty darn large. I mean, one of the problems we have in the Hive metastore is that you can't always, we have 4,000 characters for a schema, and many times it just doesn't fit. The events in Kafka are usually smaller than 4,000 characters, so it's really not the right thing to do. We need to, as a community, to come up with a better solution. We don't really have that yet. And last thing, I don't really want to sound vendor specific, but I'm so, so proud of it. We just added Kafka to Cloudera Manager. We have a bunch of reports. You can control the configuration. You can view the logs. It's really, really awesome. Yartet that sits somewhere around there, over here, down there, actually did all of the work, and it's really, 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 really cool. So if you're into Cloudera Manager kind of graphs, then you have to check it out. It's really nice. And we also do demos in the booth, and one of them will be of Kafka, and I think I saw Jeff Holloman somewhere who can tell us when he's doing that. Okay, maybe I'm missing Jeff Holloman as well. So I cannot tell you when is that, but if you drop by our booth and ask, I'm sure someone will tell you. And I'm done, so if there are any questions. Okay, I guess you were all pretty good. Oh, we'll talk later. I will repeat the question.
Just repeat the question. Can you speak just a little bit about how offsets can be committed in a Spark streaming workflow? Like,
Okay, so it is a problem in the Spark streaming workflow, because the question was how are offsets committed in Spark streaming? And this is actually a pretty large gap currently, and something we're working on. Currently, Spark streaming doesn't actually tell us when the data was persisted to disk by Spark streaming. So we kind of have to guess. So at this moment, if you download the latest receiver, you will still have auto-commit, which is not really what we want. At the next version that's coming out, we will fix it to commit a bit too late when we're absolutely sure that the data hit disk, which may lead to duplications. And at some point, I hope we will fix up Spark streaming enough to allow actual committing, doing kind of a two-phase commit, the way we currently have, for example, in the Flume source, that allows us to minimize the window in which you can have duplication or data loss. Does that answer the question?
Thank you.
Yeah. Okay?
Another question.
Oh, okay. Yeah.
It's a follow-up to that. I'm just wondering, so in reading through some of the Kafka docs about offset management, like there's one option to put it in Zookeeper, but then there's also managing offsets in target systems.
Yeah, so Camus, for example, manages the offsets in the target system. Flume and Spark streaming manage the offsets in Zookeeper.
They manage it in Zookeeper?
Yeah.
Okay.
Is that a problem? I mean, I didn't see a problem with that.
Why? In terms
It's a good place to manage offsets. Why not? It's fast to write to. It's way faster than HDFS to write to. It's we found it's central. Everyone has Zookeeper, so yeah, we kind of like it. We manage it over there. As far as I know, Storm is doing the same thing, by the way. Okay.